Okay, so what we have here are solving log equations. When we are solving log equations, it's really important that we talk about what we have two different types of log equations. All of these on this page, we are talking about these are type 1 equations. These are type 1 log equations. What I mean by that is that every single term has a log piece in it, meaning there is absolutely no constant term. Or no term without a log. Now, let's go ahead and look at these. Solving these equations, there's another important thing to remember, and that is that we have to remember the domain of the log. What that means is inside here, our final answers, whatever our argument is, must always, the log of u, whatever is inside u, must always be greater than 0. Not greater than or equal to 0, but strictly greater than 0. All right, this first type of equation is really straightforward because what I'm saying here is the log of this expression must equal the log of this expression. All we're doing when we are down to log of a is equal to log of b, all that means is that a has to equal b. In this case, it means that x plus 5 must equal 2x. I solve this for x, and I get that x must equal 5. The check for this, if I plug this back inside here, what that means is, does the log of 5 plus 5 equal the log of 2 times 5? And yes, log of 10 is equal to log of 10. So coming over here to the next equation here on the right-hand side, I'm going to give this a little bit more room because something happens with this one that we have to take care of. So this is the same idea where I have the log of everything inside here must equal the log inside here. The difference is when I'm setting this up, I have a quadratic equation. I have x squared plus 5x must equal 6. This is a quadratic equation. I have to set this equation equal to 0 and solve. I can do that by either factoring. Sometimes you may need to use the quadratic equation. In this case, I just need to move my 6 over to the other side. So I get x squared plus 5x minus 6 is equal to 0. Now, to factor this, I have to have x in my first two terms pieces here. I need to have this be a positive 6 and a negative 1. So the two solutions that I have here is that x must equal negative 6 and x must equal 1. Now, because of the domain, we must check the domain. Now, in both of those cases, when I plug them back in, if I plug that back into the negative 6, I have log of negative 6 squared plus 5 times negative 6. Is the end piece of that positive? Yes. 36 minus 30 is positive, so the solution works, and the 1 also works when I plug that back in. All right, let's go ahead and come down and look at my next example that I have here. This example is a little bit more involved because if you'll notice, this is not in the form of log is equal to log. That's our first goal. What I need to do with that is go through and take both of these pieces of logs and I need to condense them. By condensing the logs on that side, the negative turns into my log base e, or my natural log. Let's write it as a natural log. So what I have here is my natural log of 2 over 3x plus 2 needs to equal log of 2x. Again, let me fix that. That should be... All right, so it looks like I have a typo in my notes here, so I'm going to go ahead and change this. Otherwise, we would not be able to do this. We're going to turn that into a natural log. Sorry about that. If that was truly the natural log on one side is equal to log base 10, we would not be able to do this question. So I'm going to go ahead and change that to a natural log. Now we can go through and fix that. So now what I have here is, since it's down to the point where it's in log is equal to log form, I just set the two interior pieces equal to each other. So it is 2 over 3x plus 2 is equal to 2x. Put that 2x over 1. What we're going to need to do with this is solve this equation. So I'm going to go through and multiply both sides of this equation. Doing that, I have 2x times 3x plus 2 is equal to 2, or I have 6x squared plus 4x. I'm going to go ahead and take this 2 here and move it to the other side. Minus 2 is equal to 0. Now, I can factor it the way it is, but it's also a little bit easier if I factor out the GCF first. So I'm going to go ahead and take out a 2. Then I'm left with 3x squared plus 2x minus 1 is equal to 0. Continue to factor. That first term is prime, so the first term must be 3x and x. The only choice I have for my last term with 1 is a 1 and a 1. But since I want that to be a positive 2, I need to put a positive here. And I'm going to have to go ahead and subtract and make that a negative. So the answers that I have here are x is equal to 1/3 and x is equal to -1. Because of the domain issues, we need to go through and check this. We need to make sure that what I have here is and fits within inside that domain. If I go through and look at 1/3, 1/3 when I plug it in for both places are going to be fine. But let's check this other side, the natural log of 2 times -1. That's going to give me the natural log of -2, which is outside my domain, so that x is equal to -1 I have to throw out. And the only correct solution that I have here would be x is equal to 1/3. All right, let's try one more example. I'm going to pop over here to the other side. And again, the first thing I'm going to want to do with these is, because it is not in the form log is equal to log, that's the first thing I need to do. So I'm going to go through, and on the left-hand side of this, I'm going to go ahead and condense this. I'm going to go ahead and condense that using the multiplication rule, knowing that this now becomes log base 5 of 6 times 2x squared is equal to log base 5 of 48. Now that's inside this form. Everything inside the arguments can go through and equal each other. So now I have 12x squared is equal to 48. There are a few ways to do this. The way I see first is to go through and divide both sides by 12. I do that and I get x squared is equal to 4. When I take the square root of both sides, I get the fact that x is equal to plus or minus 2. Now, like I said, we have to check the domain. And in this case, the only place that has a variable is that middle piece. So if I look at log base 5 of 2x squared, notice that x is always going to be squared inside here, so both work. For this equation. So don't automatically think that because an answer is positive or negative, it will be included or excluded. You must go through and check your solutions for this.